This video is about the log operator. This operator records data to the RapidMiner log. This data can provide information to help understand processes better and can be used to control the execution of a process. The log operator is quite simple, but really can only be understood if you look at it being used in the context of a larger process. So for the purposes of this video, I've created such a process, and it uses a number of other operators. These are generate macro, loop, log to data, guess types, delay, and provide macro as log value. This video won't go into any detail for these. There are other videos for that. Hopefully though there'll be enough to give you a flavour of what's going on. As we proceed, we'll obviously look at the parameters to the log operator. These include the log parameter itself, which has some detail below it, the sorting type parameter, and then the file name and persistent parameters. Okay, so the first thing, let's look at the process. It has a number of operators as I described, so let's go through them one by one and I'll explain what the process does. This first operator is a generate macros operator. This simply creates two macros which really are used to set up the initial starting conditions for the process. So essentially what I'm doing is calculating a time when I start and a loop counter, a loop time rather, which I'm setting to 0. I'm going to be recording this from the log operator. Then there is a loop operator itself. Now this contains more operators. We'll look at those in a moment. This loop is set to iterate 1000 times. Therefore everything inside this operator will run 1000 times. If I double click on this icon here, we can see these are the 5 operators inside the loop that get executed. The first one is called delay. This is simply a 30 millisecond delay. I'm doing this to allow the loop operator to run more slowly so that we can see it execute it and get a sense of what the log operator is doing, which is what this operator is here. In between the delay and the log, I'm calculating some macros. The first generate macro operator to do this basically works out the time now. So whenever it's called in one of the 1000 iterations, the macro called now will be populated with the date and time now, and this is relative to the epoch. I'm also doing a bit of advanced macro generation. I'm working out the delay amount for the delay operator above. It's 30 milliseconds. So rather than type 30 in here, I decided just to populate it from one of the parameters to the delay operator. The next generate macro operator, that calculates a loop time. So essentially it's doing a difference between the last time and this time and then it's subtracting the 30 milliseconds. So what essentially is happening here is I'm calculating how long it takes for all of the operators inside the loop to execute, and it should always be greater than 0 and will no doubt vary as the load on my computer changes. And then I'm doing another calculation to reset the baseline times for that calculation the next time round. And then the final operator here is this is a provide macro as log value operator, where I'm allowing the macro called loop time, which I'm calculating inside the loop, to be available to be logged. Then we get to the real meat of the video, which is the log operator itself. So what you do with the log operator is you select things you'd like to log. So what I'm doing in this is simply logging two things. I'm logging what iteration we're at the moment, and you can do that by looking at the loop operator. You select it from this drop down. This is the list of all of the operators in the process. So I'm choosing loop. I'm choosing the value of this iteration. So in other words, this is a particular variable that is incremented each time, and it's personal, as it were, to the loop operator. And by using these three parameters, I can then record that value and place that in the log file, and the column name will be apply count. The second thing I'm doing is I'm taking advantage of the provide macro as log value operator, which is essentially allowing me to record the value of loop time, which is a macro, and essentially I'm recording loop time, the value of loop time as calculated, into the log. So we should see a column called loop time and a number greater than 0, greater than equal to 0 probably. So if we come out of this loop operator, remember this loop operator contains these processes. So if I press this button here, we go up to the one above. This is the high level, the top level process. The final two operators not really needed, but just there for completeness to make things a bit neater. This operator converts the log to an example set, makes it a bit easier then to store or extract things from if you want to later. And this one is a guess types operator, which changes nominals, which are the default things logged by the log operator, to numbers, which again might be useful for modeling or whatever you want to do. So that was quite a long introduction. Let's quickly recap. What this process will do is it will run 1000 times. Inside this loop, a calculation will be made which essentially will give us a timing for how long the loop took to execute. That information will be recorded to the log, which is inside this loop, and at the end of the process the log will be converted to an example set and we'll be able to look at it. Okay, so let's run it, and while we're running it we can actually examine in real time what's happening. So I'm going to run it now, and I'm going to switch to the results view quickly where we can observe what's happening. So if I do this, I'm running it now, switch to the results view. If I go to the log tab, table view, hopefully you can see here it's showing that the number of rows that have been written to the log is incrementing quite quickly. It's also down here as well. And when that gets to 1000, that will stop. So, and at that point the log, which is this tab here, will be converted to an example set. The log will be retained actually. So it's finished. Now we have an example set. Going back to the log quickly, you can see indeed there were 1000 rows, and if you remember the parameters to the log operator, apply count and loop time. Now apply count should go all the way up to 1000, means that one less than 1000. If I click this like so, you can see 999 is the last time it was applied. Okay, so that's 1000 iterations, so the maths works. Each time the log operator is called, a loop time is also logged, and that is always not 0 or more, and the maximum is, let's see, well we can't sort this because this is of type nominal. So if I go to the example set, it's a bit easier now. If I click this, we can see that the maximum loop time that was logged was 43. This is milliseconds, by the way. And we can actually start to do some interesting things. We can plot graphs now of what's going on. If I do a histogram of the loop time and I set the number of bins to about 50, we can see, well, let's do it to 100. You can see as I change the number of bins, you can get a sense as to what the distribution is like for the loop time as recorded during that process. So most of the time it's that 0, 1 or 2. If I go all the way to 100, we can see that 0, 1, 2, something like that. But you can see there are 1 or 2 outliers. I mean, this is merely a way of giving visibility of actually what's happening in the process, and also maybe this information could be quite useful if you were trying to work out why something was taking longer than expected, perhaps. I don't know. Okay, so let's go back to the process. Again, refresh memory on what actually is happening in the log operator. So if you remember, the parameters that were passed to it were essentially an apply count column derived from the value of the iteration that the loop operator maintains, and a loop time column derived from the macro calculated in the loop. Okay, and you can see you can go on adding more and more entries here, and you have a lot of flexibility really depending on what the operator provides. The operators in general provide a lot of values that you can report. They also have parameters that you can get access to. Depends on the operator. And obviously the macros themselves, by using the provide macro as log value, you get almost anything really. Anything you can calculate in a macro can be logged. Okay. So let's look at the other parameters to the log operator. The first one is the file name. So what I'll do is I'll put a file name in here. I'm on a Windows machine, so I'm going to give it a rather creative name of log.log. If I save that process and run it, so I'll go to the results view, you can see it's running. I happen to have File Manager open here. It's a Windows machine, so see temp log.log, here it is. So when this process finishes, a file will be written here. Here it goes. Oops, it's overwritten. It's gone to the back. So here's, as if by magic, here is a file. If I open that with a handy editor, we can get a sense of actually it's exactly the same data. So 0.0.1.14.2.1.3.0. You can see that the example set and the log file as written to the disk are identical, which is nice. Go back to the design view. If you look here, there's a persistent flag. That merely writes the log file in real time rather than waiting until the end. So again, I'll delete the log file here. Okay, and I will run the process again, and we'll see that the log file will appear immediately rather than after the process is completed. So I'm running the process now. Quickly bring back File Manager. Here it is, and hopefully you can see down here this is incrementing, and the file is hopefully getting slowly bigger. There it is. Yep. So when that completes, it'll be the same as before. But this would let you look at the execution of a process in near real time rather than having to wait for a long process to complete. That might be useful in certain situations. There we go. So it's finished, and sure enough was a log file. So the final parameter we'll look at is top K, opposite to bottom K, but I guess you can work out the difference between the two. Let's use top K. Let's set that to be the top 10 and set the dimension to be apply count. What this will do is only show the top 10 where apply count is in the top 10. And let me show you it running. Go to results view. You can see what's happening is it's only showing the top 10 apply count that it's seen, and this is a way, I guess, of seeing how it's currently executing. You could also do it for loop time, I suppose. I observed that it tends only to remember the top 10 doesn't apply any order to them, so if one comes in that's higher than the last one it sees, there's a risk that the genuine highest will be flushed out. But this can be quite interesting to see just the top 10 last ones, essentially, where there's an apply count being used, which allows you to sort by that value. Okay, so let's go back and let's put that back to none. So let's just run this one more time with the full example set. I'll run that one more time, let it run all the way to the 1000. And at the end I'll bring up the example set so you can see the values for yourself. So here's the final example set. If we we can look at the statistics and the charts. Let's use the chart of the distribution of the times for loop time. Perhaps that's the thing that's interesting. Also, we'll go back to this just to show this is the final parameters, that you can see where that data comes from.